Okay. Yeah. So today we are going to discuss about. Let me check. Yeah, Azure storage. Today we are going to discuss about Azure storage. Before I start this, so do you guys have any questions till the syllabus which we have covered till now? Have you guys able to finish the entire lab setup and all? Are we good to
Yes.
proceed?
Yes.
Yeah. So I'll proceed with Azure storage today. So the most important topic or the component of Azure is Azure storage, because that is where you store all the data related to Azure virtual machines, or where you can securely store your archive data, or where you can put all your files on Azure. So without storage, you will not be able to keep your files on Azure. So let's talk about agenda for today. So today's agenda is Azure storage overview. What are the kind of storages we have? What are the kind of versions we have in storage? And what are the kind of services we have in storage? And about storage replication and about storage security. So these are the things which we are going to discuss today. So Azure storage overview. So what is Azure storage? Azure storage is a scalable, durable, and highly available storage solution. So you can scale it in the sense, if you want 100 terabytes of data, you can easily go ahead and buy it, right? If, you only bought you only created a virtual machine with 100 GB of disk today, but you can go ahead and expand that to 1 terabyte tomorrow. So that is scalability, right? So if you want space, or if you want data or disk storage, you can easily scale it. And durable and highly available solution. Let's say if you have your virtual machine in East US, you can replicate the data to West US. That is high availability, right? So your virtual machine is available in both the location. If there is a system down in primary location, you can easily get the data from the secondary side. So it is highly available solution as well. Use an auto partitioning system that automatically load balances your data based on the traffic, and is accessible from anywhere in the world. So you can access from anywhere in the world. Let's say you have created a virtual machine, or you have stored your data in East US, but you can access your data from India, from Hyderabad as well, or from your home, from US, or from any other location. So it is accessible from anywhere in the world. So from any type of application, whether it is running in cloud, on desktop, or on on-prem server, or from a mobile or a tablet. So you can access your data from your desktop, your mobile, or a tablet, or any kind of device which is connected to internet. Support client using a diverse set of operating system, including Windows, Linux, and variety of programming languages. That is .NET, Java. Those are the some of the examples. So you can store Windows related VHDs. That is Windows. You can create Windows virtual machines. You can create Linux virtual machines, and you can also keep data related to different programming languages. That is .NET, Java, Node.js, and Python. These are some of the examples, and all these programming languages are being supported with Azure storage. So that is the concept here. So we spoke about Azure storage. What is the overview on Azure storage? Now we are going to discuss about what are the services provided by Azure storage. Let's go to the next tab. Azure storage services. Azure storage provides the following 5 services. That is, the first kind of service is blob storage. The second one is table storage, queue storage, file storage, and disk storage. Among this, the most important, or the ones which we are going to deal with every day-to-day operations of Azure, or blob storage and file storage and disk storage. So these are the 3 things which you have to remember. And blob storage stores. What is blob storage? The first one is, what is blob storage? Blob storage stores unstructured object data, or blobs, and can be typed of type text or binary data, such as documents, media files, or applications. So blob storage is nothing but where you can store a large amount of unstructured data, like your media files, like your photos, like your JPEG videos, or VLC videos, or any kind of data, or you can keep your VHDs, or you can keep any kind of data in blob storage. It is like you can keep your unstructured data, which do not have a schema, which you do not have a structure. You can keep all kind of files in a blob storage. So I'll take you to Azure, and I'll try to create a storage account first, and then we'll try to create a blob storage and see how it looks like. So for creating any kind of storage on Azure, the first thing which you have to create is a storage account. Storage account is a container for all your storage types, that is blob, table, queue, or VHD, disk type of storages. So the first thing, if you want to create a storage on Azure, the first thing which you are going to do is create a storage account. See this storage account, it is a container for blob, file, table, and queue. So if you can read this, you will be able to understand what is that we are creating. Microsoft Azure provides scalable and durable storage, and it is also cost effective, and it is including it can store the unstructured type of binary data such as videos, audios, and images. So in order to create this, what we are going to do is just click on create button. So our subscription is a free subscription. Resource group, I'll take test SNIT, and storage account SNIT test. I cannot use a capital letter here. Okay, so you see these locations here. So I can create my storage account wherever I want. Let's say I am in India, but if I am creating in East US, so in order to access my files, there'll be a latency. So if I am in India and if I want to create a storage account, I have to create which is the nearest location for me, right? So if I'm in India, I can create in Central India. I just type in. I can create in Central India or South India or West India. Let's say all your production virtual machines are running in East US. Your company has a head office in East US, and you are creating resources in East US. Then you can create your storage account in East US because all your storage resources are in East US. Now we are creating a resource for our company in India, so I can select any of these regions. So that is, I'm in South India, so I can select South India. So there are like two types of storage accounts here, that is standard and premium. So what is the main difference between standard and premium? Standard is like the main difference is the performance, the number of IOPS it can handle, right? Standard is like normal HDD of our machine. Premium is like which can handle more IOPS and which will be faster than standard. So for now, I'm going to click on standard. So I can see three type of storage options here. That is storage V2, storage V1, and blob storage. Storage V2 is the latest version of storage which can store more amount of data, and also it has hot, cold, and archive store. I will discuss about what is hot, cold, and archive storage, and this is the latest version. So if you do not have any dependency on V1 version, you always select V2. And the replication time, we're going to discuss about this replication type in the coming slides, but for now I'll be selecting LRS. Before this, let me go back to the slide, and let's talk about the first we'll try to understand more about what are the types of replication, what is hot, cold, and archived here, and then we'll go to the creation of the storage. So these are the types of storage services which we have: blob storage, table storage, queue storage, file storage, and disk storage. And this is segregation on depending upon the type of data which we are going to store. In IaaS, infrastructure as a service, where we create virtual machines and all, we mostly deal with disk and file shares. So it is you only using disks and files. But in PaaS, where you install web applications, databases and all, they use blobs, tables and queues. So tables are used for structured data. That is for databases where you have tables and all. So it will be used for that type of storage. If you're creating a database or if you're putting a lot of structured table data, then you can select a table storage. Queues are for messaging in the sense, if first in first out and asynchronous messaging kind of thing, data, you can use queues, but mostly we'll be using disks, files and blob storage. Here you can see the data, that is the segregation. For unstructured data, we can keep the data on blobs, data lake, Mongo database, files, queues, and disks. For structured data, that is structured databases, you can use DocumentDB, Azure SQL DB, or SQL Data Warehouse. This is just for information, guys. So you don't have to worry about if you're not able to understand. It's just for information. Okay, and tables for structured data. So blob storage, what is a blob storage? So Azure Blob Storage is a service that stores unstructured data in cloud as an object or a blob. So you can upload any kind of data to blob storage. So let's say you have images, you have videos, you have VHD files, or you have any other data. You can keep that in blob storage, right? So any kind of unstructured data, any kind of binary data, you can keep it in blob, right? Azure Blob Storage is a service that stored unstructured data in cloud as an object or a blob. Blob storage can store any type of text or binary data, such as documents, media files, or application installers. So you can create, you can upload MSI files, you can upload exe files, .exe extensions, you can upload text files, you can upload VHDs, and you can upload media files and videos, any kind of data. You can keep it in blob. Blob storage is also referred to as object storage. Azure Storage offers three kinds of blob. In blob, we have three kinds of blob types. That is block blob, page blob, and append blob. Let's talk about the differences. This is how the blob look like. Let us go back and let's start deploying. I'll show you guys how a blob look like. Next, review and create. So we are going to create a Microsoft storage account with the name test SNIT. So deployment logs can be viewed in deployment. Operation details. So this is what we are trying to perform. So provisioning operation, it is creating provision and state, it is running, and for what duration. Refresh and done. So if you want to go to this resource, you can directly click on go to resource. So guys, this is the storage account which we have created. The storage account, in the sense, it's a container. It's a container for all the storage types. Now the blob is called a container. So there is no blob naming convention anymore. It is called as a container. So if you want to see the blob operations, you can directly go into this container configuration. You see this? This is what we have created. Storage purpose V2, performance standard, and access tier hot, replication type LRS. So this is for this thing. So let's say if you want to upload any kind of data, or if you want to upload to this particular blob. So what you can do is you can click on this blob, add container. Let's say test blob create. So this is how you can create a blob in storage account. So you can access this blob. If you want to upload any kind of data, you have a upload option here. You see this? You can upload. Let's try to download a simple file and try to upload it onto Azure. Let's say I have like 100 images on my machine. I want to upload it to Azure. So let's try to download something from Google. File over cool logos. So this has a zip file with 300 logos, which we are going to download, and then we'll try to upload and see how it looks like in Azure. Let's say I'll open this folder. I'll try to extract this. And then these are the pictures I have. So these are the logos I have. So what I'll do, I'll try to upload this to Azure. So how can I upload it? How can I upload a file to a storage account? I'll click on storage here, storage account, and then I'll click on the storage account which I have created, and then I'll go to containers, and I've created a blob here. I'll click on that blob and I'll say upload. So it'll be asking to select a folder. I'll go to downloads, and then I'll say my logo folder. Click OK. Open. Upload. So you see this, the files are getting uploaded to Azure, right? So all these 300 files which are in my machine are now uploaded to cloud. So now I can see those machines are uploaded, those pictures are uploaded to cloud. See, you can access here. So these are the properties of that cloud. If you want to download it from to a different location, you can give access to that user so that he can download it to his machine. So that is how you can upload something to a blob, right? So this is the blob, and this is how you can give access or give permissions to a particular user on a particular blob. And this is the URL which talks about the blob name. The blob name is SNIT test, which we have created. And for each of the blob, it will be the blob name dot blob dot core dot windows net. So this is the blob name which it takes when we create a storage account. So that is what it is explained in the PPT here. So if you see this, you have a HTTPS colon // account, the storage account which we have created dot blobcore dot windows dot net, and then the container which where the images are stored, and then the blob name. So the container name which we have created is a blob, right? So this is the blob which we have created within the storage account. So let's say if I go back and create another container, add SNIT test new container, and I'll say blob type, and I'll say create. So if I go to this SNIT container and go to properties of this, what I can see here is HTTPS colon // storage account name dot blob dot core dot windows dot net forward slash and the container name. So what is the container name which I have created? SNIT test new container. So that is what it is talking about, this URL, right? The container name or the blob name. So let's go to the next slide, that is blob types. So I told you, like in blob we have different blob types, that is blob, page blob, and a append blob. These are the three type of blobs we have. So what is a blob? So blob is used to upload stagnant data, that is the data which is very small and also is not changed randomly. In a sense, let's say images will be in MBs or KBs, right? So and then you'll have a lot of hundreds of images. In that case, it will try to create it in blocks of data, that is like each image is a block, as appeared as a block. Let's say image1.jpg. You see this image1.jpg, it is created as a one block. In that way, if you upload hundreds of images, right, then it will be created in each of the blocks for image. So that is blob. So for blob is used to store data which is very small and which you have in repetitive way, in a sense hundreds of images. So that is a blob. What is a page blob? Page blob is used for randomly accessed data. Like let's say you create a virtual machine and then it has a VHD, right? So this VHD, whenever the operations happen, in the sense, whenever you try to read some data, write some data, it will be a continuous process. So in that case, what we use is a page blob, because the IO operations are random and it will be continuous. So for this operations, you use a page blob. So that is a difference. So blob is used for small amount of small sized data objects, and page blob is used for randomly accessed data. So this is used for random read and writes. That is, example is VHD. VHD is a random read and write. So, and it is supported up to 8 terabytes, and blob support up to 4.7 terabytes. That is a hard limitation. So the third one is a append blob. So let's say today you have uploaded or you have uploaded a file onto Azure. So tomorrow if someone comes and writes to that file, what it will do is it will not try to modify the existing block. So it will try to append a block and try to write the changes onto that block. So that is nothing but append blob. So let's say you have a data today. Tomorrow someone tries to access the data and change the data. At that time, it will try to append or add the data to Azure and not to modify the existing block. So that is nothing but append blob. That is a third type of blob. So blob name we have already discussed. And the next one, which we are going to talk about, is hot, cool, and archive type of storage. So let's say I have a virtual machine, and that is a Windows machine, and then I have some data on that. It's just a test machine. So on the data on that machine is not randomly accessed, and it is just a test machine which someone logs in weekly once, and then there is no much of a IO on that. So that is not fully utilized data. Let's say I'm talking about a data which, or a machine which is logged weekly once, and the data is not even used randomly. So in that case, what you can use is a cool storage. Cool storage is nothing but you don't have high number of IOPS, you don't have random reads and writes, you don't have much utilization of a storage account, right? So in that case, you can use cool storage because your data is not randomly used. And then the storage cost is also less for cool storage, right? So when you compare that with the hot storage is nothing but if you have an application machine or a web machine where the IOs are randomly written and randomly read, right? So there'll be a lot of changes, a lot of data written to the disk, a lot of changes happening to the disk, and then there'll be a lot of web requests coming in. At that time, you have to fetch the data very quickly, and then you have to serve the request to the customers. In that case, we'll create a hot storage because there will be a lot of activity happening on the disk, and then there'll be a lot of reads and writes, right? So in that case, we'll create a hot disk, and then for that, the costing will be a little more than the cool disk, right? Because that is serving a lot faster the requests which are coming in. So archive storage, let's say you have a terabyte of data, that is your company's data, and your company policy is to keep any file for, like, let's say your company's policy is to keep any file, let's say, for 10 years, right? Whether it is used or whether it is not, you will be asked to store data for 10 years, but the data is never used. It is just the old data which is there for your company, and then it is never used. It is just the company policy. We have to keep the data. So that is not randomly read, and randomly there is no writes onto that. It's just the old data which has to be stored. In that case, what you use is a archive tier, because the pricing for that archive tier will be very, very, very less when compared to hot and cool storage. So cool storage is for very less usage of disk IOs, reads and writes. Hot storage is for very frequent usage of disk IOs, reads and writes. And archive storage is for archiving the data, that is storing the data for a longer retention time. So that is a difference between hot, cool, and archive storage. So we can talk about a blob type of storage here. Blob storage account hot, data that is actively used. So you see this data that is actively used, you can create a hot storage. So if you create a cool storage, short-term backup and disaster recovery data sets, or you can keep it for inactive data, that is cool storage. Archive storage, long-term backup, secondary backup, and archival database. So if you want to keep it for a longer retention time, let's say for years, for a stagnant data, so you can use this archival kind of storage. For high volume infrequent access data, new tier, same API and durable, similar latency. Pricing to match workloads. Hot storage, higher standard, higher storage cost, lower access and transaction cost. Lower storage cost, higher access and transaction cost. So that is for cool storage. Lower storage cost, higher access and transaction cost, that is for archival storage. Storage charges may apply in the same way. So for which one is the costlier storage? That is hot, because it serves more IOPS, and then it is randomly accessed. So the medium costing one is cool storage, and very cheap storage is archive storage. So pricing and billing. So how is the storage cost, storage account charged, or a disk usage charged? So storage account is charged per gigabit. Cost decreases as the tire gets cooler. In the sense, let's say per GB, if archive storage costs like 1 rupee, then cool storage costs like 3 rupees. And the hot storage costs like 6 rupees, right? So the hot storage costs more than the other tiers, and the cool storage costs more than the archive tier. Data access cost increases as the tier gets cooler. For data is cool and archive access tier, you are charged per GB data access charge for read. So for the data access charges, it will be charged again according to your storage account or the disk which we have created, and then the per GB level. So transaction cost, there will be a per transaction charge for all tiers that increases as the tier gets cooler according to the tier which we have created. Geo-replication data charges apply to the account with geo-replication configuration, including GRS and RAGRS. So let's say your data has been replicated to another region. So your data set is in region A and it is getting replicated to data region B. In that case, you will have 2 copies, right? So that the cost of storage will be doubled. So if there is a replication set for the data, your cost will be doubled. Outbound data transfer cost. Data that is transferred out of an Azure region incurs billing. So egress traffic will be billed. Ingress traffic will not be billed. In the sense, whatever the data which is going into Azure is not built. So whatever data which you are trying to download or access, it will be built. Changing the access tier will result in the tier charges changes for access tier inferred blob storage in an account. Let's say you want to change the tier of the storage from cool to hot. Let's say that is going to happen, but the pricing or the charges will be increasing according to the tier you have selected. Archive storage. We already discussed about archive storage. So that is for longer retention period. So let's say your company is like having a policy of 10-year retention data, then you can keep the storage, inactive data storage in archive store. Instead of data that can tolerate several hours of retrieve latency and will remain in active tier for at least 180 days. Is enabled on blob and not a container or a storage account. While a blob is in an archive tier, it is offline and cannot be read. So it will not be read. If you want that data to be retrieved again, you have to raise a request and then it will take hours to retrieve because this is the cheapest storage. You cannot take a snapshot of this blob. You cannot take a snapshot. To read the data in archive storage, you must first change the tier of the blob to hot or cold. This process is known as rehydration and take up to 15 hours. So if you keep your data in the archive tier and you want to access your data, then you have to change that access tier either to hot or cold so that you can start accessing your data. And this conversion process will take up to 15 hours to complete. That's why I told you it will take hours to retrieve the data. So usage scenarios of archive tier, we already discussed long-term retention, backup and secondary backup and archival data sets. Original raw data that must be preserved even after it has been processed into final usage form. So if it is, have to be stored just for the company policies. Compliance and archival data that needs to be stored for a long time and is hardly accessed ever. So it do not have any use of accessing. It can be hardly accessed in the sense we do not have any use of the data, but it has to be there for years. So that is that kind of data we can keep it in archive tier. Storage tier comparison. So this is what we have discussed: archive tier, cool tier, hot tier, and premium performance. So availability of this will be offline archive tier because this is not accessed. If you want to access, you have to convert to any of these two tiers and then access. Cool tier 99% is availability, hot tier 99.9, premium performance 99.9. Availability sets, you can, there is no availability of highly availability of archive tier, but hot tier and cold tier you can be make it highly available across different region. Usage charges, high standard cost, lower access and transaction cost. So we already discussed this. Just a table of comparison. Minimum storage duration, this is 180 days, then it will be going into archive tier, and 30 days this will be going into cool tier. Hot tier is randomly accessed data. So latency it will be hours to retrieve the data, milliseconds to retrieve the data, milliseconds, and a single digit millisecond for the premium tier. This is the costliest and the fastest tier, that is premium performance tier. So let's talk about the topic called soft delete. So I think I have already discussed this option before, but let's talk in detail about this. So let's say you have a disk or you have a storage account, and a rogue user or someone who is new to your company logged in and accidentally deleted that storage account, and you do not have a backup. So what happens then? So your data is lost. So that's the reason why Azure have come up with this soft delete option, saying that once your data is deleted, it is, let's say your data is accidentally deleted, still the data will be there for a certain period of time. So let's say if I go back to my Azure account, let's say this is the container which we have created. So if you want to access that, overview, See this? So blob soft delete. So let's say if I want to enable this soft delete option. So I don't want this blob to be deleted or accidentally deleted. So blob retention period is by default it is 7 days. I can increase that to 365 days on a minimum. So let's say if I want to keep that, if the data is deleted, still I want to keep that for 30 days, and then the data will be completely deleted. So that is how a soft delete option is enabled. So it says that once the data is accidentally deleted, then still the data will be there for like 30 days according to my setting. But the maximum is like 365 days. You can keep up to 365 days, but the data cost will incur, right? So after the data deletion, still if you want to keep the data cost will incur, but it will be there for like 30 days according to my setting. So that is a soft delete option. Table storage, we already discussed about table storage. Azure table storage is a service that stored large amount of structured data, that is about databases or tables. Table storage contains the following: URL, storage accounts, tables, entity, and property. So table storage, it will be the same. So if I go ahead and create a table storage here, SNIT overview, and add a table test. So this is the table storage, and this is the URI. URL is storage account dot table dot core dot windows dot net. For blob, it is storage account dot blob dot core dot windows dot net, and the blob name here it is a table name. So that is the structure of a table. Entity properties. This is just for informational. No fixed schema. You can create any kind of data on these tables. Queue storage. Queue storage is for messaging. Let's say first in, first out. Let's say whoever comes first into that queue, he will be going first. He'll be going out first. Let's say it's a queue where you're going in, and whoever comes into that queue first, he will be leaving the queue then, right? Whatever the other guy does, but you will be the one who is going to leave the queue if you enter that queue first. So let's say I'll try to show you example. Go to overview, and I'll try to create a queue here. So let's say I'll add a queue, that is Q1. Okay. So this is the message which we have entered first. Q2. This is the second message which is entered. So third one is Q3. So these are the three queues which I have created, right? So let's say I'll go to overview of the queue. So add a message. Let's say I'll add the test one message. So it will be expired in 7 days. I'll add a message to test 2 that is going to expire in 7 days. So then to the queue there is a third message which entered, and it is going to be for 7 days. So if I go ahead and delete test 3, is it going to get deleted? Let's see. So I have selected test 3 and I say clear queue, or no, I'll say delete message. Click yes. So the first one is deleted. It's not the third one. Whoever enters the queue first, in the sense the test one have entered the queue first. So then that will be relieved from the queue. Let's say if I delete the DQ message again, test 2 will be going, not the test 3. Whoever enters the first or whoever is created first will be leaving the queue first. So that is about queue storage. And the queue storage concept, this is the queue storage, my account dot queue dot core dot windows dot net. So for blob it is storage account dot blob dot core dot windows dot net. For table it will be storage account dot table dot core dot windows dot net. For queue account it will be storage account dot queue dot core dot windows dot net. So this is the naming convention. So now we are going to discuss about disk types. So let's say for now we have discussed about what are the storage types we have services. Now we are going to discuss about disk types. So what are the kind of disks we have for a virtual machine? So there are like two types of disks, that is unmanaged and managed disk. So unmanaged disk is the one which we used to have, which we used to use for virtual machines in older days, in the sense maybe before a year or two. We used to use unmanaged disk, that is a legacy type of disk which is managed by the user. In the sense, let's say if you want to store a VHD, user have to give the path in the storage account, right? For the managed disk, there will be Azure will be taking care of the storage disk. So you don't have to give the location where to store. Azure will store the disk for you, right? This is the initial storage model where you manage the storage account that are used to store the VHD files that corresponds to your VM disks. This is the new type of storage model where Microsoft manage the storage account that are used to store the VHD files that corresponds to the VM. This is the newest kind, and this is the legacy one. And then unmanaged disk is managed by the user. Managed disk is managed by Azure. So this is a difference. So managed disk. So what are managed disk? Azure managed disks are VHDs that are stored in Microsoft managed storage accounts. So you may not be able to see where the disk is stored. You just have the URL of the VHD. Administrator do not have access to managed disk storage account. So managed disks are not a replacement for other storage account types, that is blob type and queues, but it is a kind of a disk which is managed by Azure, not the user. So these are the managed disks benefits, some of them. This is just for information. So it can scale up to 50,000 VMs and 1,000 VMs in the virtual machine scale set. Some of the users are given here. It can be set in availability sets, availability zones, better security. So let's say go to manage disk performance tiers. So these are the 4 performance tiers we have. In the sense, standard is like just like our PCs, standard hard disk. Premium disk is SSD, standard SSD, and we have premium SSD, that is a very fast storage, and then ultra disk, that is which is having latency in single digit milliseconds. So that is the highest performing disk, ultra disk, and it is the costliest storage as well. Manage disk images and snapshots. If you create a disk, you can also take a image or a snapshot of that. That is nothing but taking a copy of that and keeping it with you. So let's say if I go here, click on snapshots. So if I want to add a snapshot for a particular disk, let's say I want a snapshot for a particular disk, I'll just say disk name test snap. I'll share it in East US. Full, make a copy, read only. I'm taking a full copy of that disk, source disk. So I'll say I just have one disk, and I'll select this, and then storage type is standard. I'll say standard. Encryption type, I don't want any encryption. Tags, I don't want any tags, and then I'll create. So what I am doing now is taking a snapshot of a disk and keeping a copy of that. It's just nothing but I'm copying that disk and keeping it for future use. So that is what we can do with a disk type storage. So the next thing is managed disk pricing. So this is how the pricing is done. Storage type billing of a managed disk depends upon which type of storage you have selected. So the type of storage, either it is a SSD or a premium disk or a ultra disk. Disk size, Azure maps the provisioning size rounded to the nearest managed disk option. Let's say you have created a disk of 100 GB, but it will try to create a disk of 128 GB, and you will be charged for that. Let's say you have increased the disk to 150 GB, but it will be rounded off to the next available size, that is 256. So the disk size will be available in 128, 256, 512, and 1024. So if you create a disk of 150 GB as well, then it will be creating you will be charged for the 256 GB. So it will be rounded off to the next nearest billing cycle or next nearest size available. So when you are trying to create disks in Azure, either you create a rounded off quantity that is 128 or a 256 or 512 or 1 terabyte that is 1024, or in any ways you will be charged for the next cycle, because if you create a 150 GB of disk, you will be charged for 256 GB because it is going to round it to the nearest managed disk option. Number of transactions billed for the number of transactions performed on the standard managed disk. Outbound traffic, data going out of Azure Center incurs billing. So which is any traffic which is going out of Azure, you will be billed for that. Any traffic which is going into Azure, you are not billed. Managed disk snapshots are billed based upon the size. So whatever the size it is occupying the snapshot, you will be billed for that. So managed disk migration, you can always migrate or take a snapshot for that. So now we are going to talk about Azure files. So in Azure, we already have discussed about, let's say, activity. We already have discussed about a container, that is blob and queues and tables. Now we are going to discuss about file share storage. File share is nothing but you create a file share on Azure. You upload all your files, and then you can access those files from your PC or from any other location, or from any other location as you require. So how can I create a file share? Let's say I have created a test file share, and this quota is nothing but how much of amount of data I can store in this file share. Let's say I'll give 30 GB, right? Create. So I can store up to 30 GB of data. So let's say I want to upload some data onto this. Let's say I'll upload these files. Upload. Upload is completed. Let's see if it is completed. I think my browser got crashed. Let's see. Let's wait for a minute and see if the upload is completed. Exit page. S90 Tech. Yep. S90. So I'll go to file share, test, and I'll see all the images. So how can I access these images? So how can I access this? So if let's say you have uploaded your data and your friend has to download it somewhere from his location. So what you can do is you can go ahead and connect. Either you just have to give the script which you see here, you can give it to your friend so that he can run the script on his machine, so that it can be attached as a drive. Let's say I'm going to attach as a Q drive. I'll go ahead and I'll copy the script, and then I'll execute this. You see if that can be executed. It's trying to connect to my source. So this is the script which you have to give so that they can access the files from his machine. Let's see if it is executed. So it is trying to execute something, attempting for the TCP connection, waiting for the response. Any questions, guys? So I don't know. Today we have a lot of topics to cover, so I may be going at a faster pace. But any questions till now? Aditya, Venkat, Hasanti, Sai, Siddhivishnu.
Based on the locations also the prices will change.
Yes, based on the location also the pricing will change. So I'll show you a pricing calculator here. Azure storage pricing calculator. So if you want a storage, right? So you can come here, view. So this is how you can select the region. So if you select East US, you will have a different kind of pricing. So if you select somewhere around South India, let's say you want a blob, standard tier, and general purpose V2, LRS hot. This pay as you go, you'll be charged this much per month. You see this?
Yes, $24 per.
$24. So that is how it is charged. Let's say I want to change that to premium, right?
Okay.
So how much am I price? It is costing to me $152.
$152.
152. So 24 and 152. That is the change.
Okay.
Right. So let's say I select East US or I select somewhere around West Europe. So that will be costing around $195. You see the change? So
Yes.
that will be according to the region as well, the pricing.
Okay.
Right?
Okay.
Yeah. I think I'm already connected, right? So what are we discussing? Azure files. So Azure file storage, let's see if it is connected. It is connected as Q drive. Let's see if a Q drive is here. Connected. Sometimes it may not show on my system because I think because of the security policies. But if you execute that command on your machine, it should be connected as a Q drive. Just MSC. But it is showing as Q drive here. You see this Q drive is connected. So on my machine, I have some issue, but you can try this on your machine. So if you start running the script, it'll be attached as a disk on your machine and you can start accessing that data, right? Whatever the file share, which we have uploaded here. Okay. So that is about file share and benefits of file share, shared access. It can be shared to any one of your choice, right? Fully managed by Azure. Scripting and tooling, it can be supported by PowerShell and AZ commandlets. Resiliency, so that is about high availability. Familiar programmability, so it is like same as your Windows share, which you are going to access, and it works for SMB. So file share components, so this just for informational. So this account share, directory and file, that's the same structure which you have for blobs and all. File share versus blob, and again this is for informational. So I'll share this PPT again, so you can just go through these differences between Azure file and disk, and the supported operating systems for file share, and what are the protocols supported. And then we'll come to Azure File Sync. Azure File Sync is nothing but you have a file server on your on premises. In the sense, you have a file server on your on premises. you want to keep a backup or you want to replicate the same file server to Azure. Instead of creating a Windows machine, again installing file server on that and keeping the files, you can create a file share in Azure and you can start syncing the data from on-prem to Azure. That means whatever the file shares which you have on-prem, it will be completely synced to Azure and then it will be updated accordingly. So whatever the data which is changed on-prem, it will be continuously synced. But whatever the data which is stored on Azure, it will be synced every 24 hours. So back to on-prem. So that is about file sync. You can sync your file server to Azure with file share. Prerequisites, it should be in the same region as a Azure storage account and deploy file server sync. At least one supported instance, the Windows server should be on the file sync agent has to be installed, and AZ modules are supported and use of AZ PowerShell module for the file sync on the supported including non-Windows. Azure sync components. What are the components which you have to install? I'll give you a link, guys, how you can install the file server, because we may not be able to do it because I do not have a file server now. But you can start deploying a Windows machine on cloud and start using that as a on-prem machine and use a file sync. But just keep this concept for your understanding. Okay. Yeah. Sync group. A sync group defines the sync to topology of a set of files. Cloud endpoint. Cloud endpoint is nothing but whatever the cloud endpoint file share which we have on cloud. And server endpoint. Server endpoint registers represents a path of the registered server. Whatever the server on-prem which is registered to Azure, it is a server endpoint. Cloud tiering is a feature that allows infrequently used or accessed file on the server endpoint to tier a Azure file. That is nothing but whatever, depending upon the accessibility. So depending upon how you are using the files, it will be giving a cloud tier to that file set. Azure file sync process, changes made to the file at the server endpoint are replicated in real time. I told you, right? On-prem changes will be synced to Azure on a real-time basis. Changes made to files at the cloud endpoint are replicated once 24 hours. So every 24 hours, the changes made to Azure files will be synced to on-prem if there is any. For larger namespace, it takes longer than 24 hours. So it depends upon the content of files you are uploading, because it has to check each and every file and then it has to upload or sync with Azure or on-prem. It may take more than 24 hours if the file share which you have uploaded is of large size. Last writer wins in conflict resolution. Let's say I have written a file now and someone have changed it after an hour. So whoever changed it at the last, it will be the file which is synced to Azure, not the changes which I have written. So the last writer wins, right? Data is replicated via HTTPS or express route. So it will be replicated over a secure channel. Azure storage account V1 and V2. We discussed about V1 and V2. V2 has a hot and cold storage tiers. V1 do not have that. V1 have standard and premium type of disks, and V1 is a legacy disk tiering, and V2 is a latest disk tiering which we got. Storage, standard storage account. The standard storage account can handle up to 500 terabytes of data per storage account, and then 200 storage accounts per region. So per each region, you can create up to 200 storage account. Let's say South India, you can create up to 200 storage account, and per storage account, you can store up to 500 terabytes of data, up to 20,000 IOPS per storage account. So IOPS operations, input output operations, you can perform up to 20,000 operations. Encryption at rest by default. So it will be encrypted at rest, all the data. Only supported premium storage account, only supported for the LRS. So what is LRS? That is locally redundant storage. Let's say I have created disk in East US location. So if I have created a disk in East US location with the option of LRS, so that is locally redundant. It will be only stored in East US, but it will be having internally 3 copies. The same data will be mirror image to 3 disks in order to avoid disk failures. So let's say I've created a disk xyz.vhd So that disk will be having 3 copies in the same region, that is East US, and it will be mirror imaged, right? So if there is a disk failure, it will be retrieved from the other 2 disks, that is LRS. So there will be an option called GRS. GRS is geo-redundant. Geo-redundant is, I have a disk or a VHD in East US. I want to replicate the data, or I want to make it highly available. So if I select GRS option on that disk, so it will be replicated to West US as well. In the sense, I'll have 3 copies in East US and I'll have 3 more copies in West US. So if there is a disaster happening in East US, I can retrieve my data from West US. So that is LRS, that is GRS, geo-redundant. So let's say premium storage only supports LRS, and then it must be used in only this series of virtual machines, cannot be mapped to custom domains. Storage analytics not currently supported for this premium disk. No support for blobs and this kind of blobs. So these are the premium storage scalability options are available according to the IOPS. Let's say if you want 10,000 IOPS, what kind of disk will you try to use? P60, because it can support up to 16,000 IOPS. Let's say you want to create a 4 terabyte disk. You create a P50 disk. Let's say you want to create a 1 terabyte disk. You are asked to create a 1 terabyte disk. Let's say you will create this P30. So that is about the different kind of premium storage scalability options which we have. Next thing is the Azure Data Box. So let's say your company is trying to move to Azure, and you have 100 terabytes of data on your on-premises which you want to upload it to Azure. So what you will do? You cannot upload it on internet, right? You cannot upload it on internet. So what are the other options? So Azure Data Box is one of the solution where Microsoft will ship the Azure Data Box to your company, so that you can start copying all the data to your Azure Data Box, and then you can send it to, you can again mail it to Microsoft so that they can upload it to cloud on the data center. You know what I'm talking, right? Let's say if I need some data from my friend, so what, and it is in his laptop. So what I'll do, I'll try to take a pen drive or a external hard disk. I'll go to his location, I'll copy the data, and then I'll use that data in my location. So in the same way, if your company wants to send 100 terabytes of data onto cloud, and you cannot send it over internet because your internet bandwidth is very low, in that scenario, so what you can do, you can copy the entire data to Azure Data Box, and then you can ship it to Microsoft so that they can upload the data from Data Box to Azure in their data centers, right? So this is just one of the option which you have, Azure Data Box, right? So that will be like a typical data box kind of thing, which is shipped for your location, office location. You can copy all the data and then you can send it to Azure or Microsoft. Azure Data Box. So this is a physical components which Azure Data Box have. Storage replication. So what are the kind of replications which we have in storage? Data in Microsoft Azure storage account is always replicated to ensure high availability. Replication copies your data either within the same data center or a secondary data center. And this is what I'm talking about, LRS and GRS. So let's go to this slide. So the first option, LRS, I told you. So if you create a virtual machine in South India, if you select the option LRS, it will have 3 copies in the same region for disk failures. But if there is a region failure or a data center failure, you will not have your virtual machine. ZRS, zone redundant. Let's say you have a data center in Khairatabad. Let's say you have a data center in Secunderabad, right? So your data will be replicated from Khairatabad to Secunderabad. If there is a failure in Secunderabad data center, you still have data center. That is zone redundant. In the same region, South India, you will have 2 data centers and data will be replicated to your 2 data centers. That is zone redundant. Geo redundant is nothing but you will have your data in Hyderabad and also you will have your data in Singapore. So these are 2 geos, right? So this is South India and Singapore is Southeast Asia. So these are two geos. So you will have data in South India as well as Southeast Asia, that is in Singapore. That is about GRS. So you'll have 3 copies in Hyderabad and you will have 3 copies in Singapore. That is geo redundant. Read access geo redundant storage, RAGRS. RAGRS is nothing but you will have data in Hyderabad location and you will have a copy of data in Singapore location, but it is just read only storage. In case of this data failure in Hyderabad, a data center failure in Hyderabad, you can only read the data from Singapore. That is RAGRS. Zero zone redundant storage. That is nothing but, let's say if you have data in Hyderabad, Khairatabad and Secunderabad, and again this data will be replicated to another location in Singapore as well. So you will have both zone redundant and also geo redundant. That is ZZRS. This will be little confusing, but once you go through that link which I'm going to provide, you may be able to understand. Slowly, once you start using the storages, you will be able to get familiarized with these topics, right? Read access zero zone redundant storage. That is nothing but zero zone redundant with a read access in a Singapore location. Next, let's go to LRS. LRS is nothing but local redundant. You will have 3 copies in the same region. ZRS, 3 copies in Khairatabad and 3 copies in Secunderabad. So 2 data centers. Zero redundant, 3 copies in Hyderabad and 3 copies in Singapore. So that is South India and Southeast Asia. Read access, that is 3 copies in Hyderabad and 3 read-only copies in Singapore. That is read access geo-redundant storage. Zero zone redundant, 3 copies in Secunderabad, 3 copies in Khairatabad and 3 copies in Singapore. So that is zero zone redundant. And you're covered with zone failures and you're covered with location failures, region failures in this. So RAGZRS. So Khairatabad you have 3 copies, Secunderabad you have 3 copies, and then Singapore you have 3 read-only copies. Next, coming about storage security. So guys, I'll just take another 5-10 minutes so that we can cover the storage topics for today. So is it okay? Can I proceed, or you guys getting late for a different appointment? I'll just take 10 minutes.
Yeah, please proceed.
Yeah. So storage security. So what about the storage security? So these are the type of accessing or storage securities which we have for different kinds of Azure Azure storage. For Azure Blob, shared access key is supported, in the sense if anyone have to access your Azure Blob, you can share the key with him so that he can start accessing the storage, right? So that is supported. Shared signature access is supported. Active Directory, Azure Active Directory, let's say his machine is connected to Azure Active Directory, he can start using that through the link provided. He doesn't need any access to that. Anonymous public read, in the sense anyone can with the link can read your data. So that is not secure. Azure Files supported for shared access key and supported for SAS, not supported, and Active Directory is supported and anonymous is not supported. Azure Files REST is supported, not supported with AAD, Azure AD, and anonymous read access is not supported. Queues and tables, accordingly, it is supported or not supported with different kinds of authentication. Authorize access to Azure Blob and queue using Azure AD. So when say if your machine, if your local machine is connected to Azure AD and it is authenticated, then you can start using this Azure Blob or queues using that. In the sense, if it is connected and if it is permitted to use, and if you have the right role-based access control, you can start using this Azure Blobs or queues. Azure Active Directory domain integration, I told you, right? So Azure VM, Azure Active Directory domain services, you connect it to Azure Active Directory, and then you can start using the Azure files if it is allowed to use this kind of authentication, Azure AD domain services. So you don't need to have a key or a secured access signature to this file. If it is connected to Azure AD, then you can start accessing these files. This is a kind of authentication. Shared signature access. These are some of the keys which you can give to access a particular kind of storage. Ad hoc signatures. Create short DS signatures. This is not required for now. Policy based signatures. This is not required. Authorized with shared keys. So let's say these things maybe we'll discuss on need basis. This I think we have discussed about changed access level, private or blob or container. So whatever the kind of permissions which we have, we can give this permission when we are trying to create a container. Azure disk encryption. So we'll talk about Azure disk encryption tomorrow. So I think we have like 10 slides or 5 slides. We'll talk about Azure disk encryption tomorrow. So for today, guys, I'll give you the labs which are required. Let me, yeah. Azure storage. So first thing, create a storage account. Create blob storage. Create a file storage. And then what else we can do? Upload some data to blob storage. Create a file storage and try to upload data and connect from your local PC as a shared disk drive. Okay, so these are 5 labs for today. So I'm going to share this file with Harsha so that we can discuss on this. Okay, are we good, guys? Any questions?
When it comes to file storage, sorry, file server, if I make any changes today, it will be just syncing it, or it will cross verify and it will upload.
See, if you're doing these changes on-prem, it'll be real-time sync. So if you're doing some changes in an on-prem file server, and if you have a sync group with on Azure, it'll be directly synced to Azure. But if you do any changes on Azure files file share, it'll be synced within 24 hours.
Okay.
So
If it is on premises, we need to mail to Azure, or
no. It will be synced directly. So you just have to set a sync group, and it will be a real-time sync. In the sense, it will be directly synced without any user interference.
Okay.
It will be a continuous sync process.
Okay. Can we change the duration like 24 hours to 48 or like that?
No, it is just 24 hours. So by default, yeah.
Okay.
Yeah. So I'll also give you that link how to set up a file sync so that you can start testing on your environments. Create a file sync on Azure. Deploy Azure file sync. So this is the link. I'm going to put that in here, this thing. This is, if you are interested, you can start doing this file sync. That requires some time, maybe an hour or two, so that you can start deploying this file sync as well. Okay, test it out if you have time. Okay, any questions, guys? No. Okay, so
and one general question,
yeah,
Like we need the Linux knowledge for Azure.
Linux knowledge is not required. If you want to go deploy Linux virtual machines, you can deploy it at a Azure level. So if you want to configure within that as well, a little command knowledge is required, but you can cope up with that. That's not required for now.
Okay.
Only to
Okay.
learn pure Azure, Linux knowledge is not required.
Okay.
Yeah. Any other questions,
Sir,
guys?
can you please share the PPT?
PPTs, yes. Harsha will share the PPTs with you, and also the
Okay.
this document with the lab guide. Okay.
Yes.
Yeah.
Yes,
Yeah.
sir. Thank you.
Yeah. Yeah. So thank you, guys. I think I have made it a 1.5 hour session today. Sorry for that. So today we have to cover a lot of topics, and we are lagging behind. That's the reason I have to extend this. So thanks for the cooperation, and we'll catch up tomorrow. Okay.
Yeah. Okay, sir. Thank you, sir.
Thank you.
Thank you.
Have a nice
Thank
day,
you,
guys.
sir.
Yeah.
Thanks.